So welcome back to the third part of the first week. As promised, we are going to start off a discussion on our second problem for the week, which is going to be about scheduling classes. So this setting is that there is a dance academy which offers classes on Saturdays for hobbyists who want to pick up a little bit of dance. So they offer classes in various styles at different times during the day. And you can sign up for as many of them as you want, but the only rule is that you cannot sign up for two classes that are overlapping. So if a class begins before another one ends, then you have to pick one between the two. So that's fairly natural. You don't want to pick classes that are conflicting like that. But at the same time, you're certainly very interested in picking up a dance hobby. So you do want to max out on the number of classes that you can sign up for. Since you don't have any prior knowledge about dance forms, you don't care which ones you sign up for. You just want to maximize the number of different classes that you can register for so that you feel like you're taking this seriously. So that is the setup of the problem that we have. So in particular, like we just said, there's going to be n classes, and each class is specified by a start time and a finish time, which we are going to denote by S and F. So if the class is P, then its start time is S and its finish time is FP. And like we said, all classes happen on Saturdays. Here is the academy's timetable. They begin at 8 a.m. and their day finishes at 8 p.m. and all their classes are scheduled between these times. For example, the tango class starts the earliest in the day, beginning at 8 a.m. and finishing a little after 10. Then you have the freestyle class, which starts before the tango class finishes and goes all the way up to noon. And then we have Bharatnatyam, which starts roughly around 9 a.m. and again goes all the way up to noon, same as freestyle. We also have ballroom, which starts around 11 a.m. and goes all the way past lunch, finishing at 2 p.m. We have hip hop that starts a little past noon and goes all the way up to 4 p.m. roughly. Then we have Odissi, Kathak, Bollywood, Salsa, Ballet, and Contemporary. So these are all the classes that are offered by the academy, and you want to pick a set of classes that are mutually non-conflicting. So that's the setting of the problem. Just to recap what we cannot do, for example, notice that you have to take a pick between ballet and Bollywood. You cannot do both of these classes, at least not in the same semester, because the ballet class begins before the Bollywood class ends. So you cannot do both. So what we are going to do is try and find our pick of a largest collection of classes that are mutually non-overlapping. Here is an example of a pair of classes that we can pick, and this example is here to emphasize that you could overlap at the ends. So the ballroom class finishes at 2 p.m. and the salsa class starts around the same time, and I'm not going to be very precise about this line here. It's really an approximate sketch, but what I want to say at this point is that you could pick a class that finishes at the same time that another class starts. We're going to assume that the instructors of these classes are nice enough to just give you some time to make the switch. So this is just a matter of convention. You could also disallow this if you like, but for the purposes of our discussion, we are going to allow it in our setting. So here's a valid example of 3 compatible classes. So you could sign up for freestyle in the morning and then switch to the salsa class, presumably after lunch, and finish it off with a contemporary class. So that's a collection of 3 mutually non-overlapping dance classes. Is this the best you can do? Pause the video for a second and see if you can find a collection of 4 mutually non-overlapping classes. They don't have to necessarily extend this selection. It could be a completely different choice of classes, but the question is, can you do more than 3? Well, I hope you had a chance to think about that. It turns out that the answer is yes, you can indeed sign up for up to 4 classes. As this example shows here, you could do tango followed by ballroom, and then you would have to rush to the Odissi class, and then you have a bit of a breather before you start off with ballet. So there is a collection of 4 classes that you can pick without having to worry about conflicts. Of course, we're never satisfied. So at this point, you want to know, well, can we push our luck a little bit more? And is it possible to find perhaps 5 classes that are mutually non-overlapping? So I'm just going to spoil this for you by saying that the answer is no, although I'm not going to try to justify why the answer is no. Feel free to take a pause here and see if you can come up with an argument to convince yourself as to why there is no collection of 5 mutually non-conflicting classes. One way to do this, of course, is to brute force through all the choices, but there is a much simpler argument in some sense, which will reveal itself by the time we are done with our algorithm. So in case it's not apparent now, remember to come back to this at the end. All right, so now let's think about greedy approaches to finding a largest conflict-free collection of classes. So remember that we want a collection of classes such that all the classes are non-overlapping in the picture that we had in mind. And there are several natural greedy choices to be made here. For one, you might say that maybe we should pick the classes that have the fewest number of conflicts with other classes, because surely those get in the way the least. So picking such classes should be good for us. So you pick a class that conflicts with the fewest number of other classes. In other words, pick every class and make a note of how many other classes it overlaps with, and then choose the class for which this number is the smallest, breaking ties arbitrarily. And then what you can do is pick this class and delete all the classes that are conflicting with it, because you won't be able to pick them anyway, and then you repeat this exercise and keep going until there's at least one class left. So that would be the greedy algorithm based on this strategy. On the other hand, you might also say, well, perhaps I want to pick the shortest class. And again, the intuition for this is similar to what we had before. Shorter classes less likely to have a lot of conflicts because they're short. And you would imagine that maybe if we pick the shorter intervals, then we will be able to span more classes. So that would be one reason for picking this greedy strategy. And the algorithm is the same. Label every class with its length and pick the class that has the smallest label, again breaking ties arbitrarily. Once you've made a choice, delete all the classes that are conflicting with the one that you've just chosen, and then again repeat this exercise until at least one class is left. Another greedy strategy that you may pick is to start with the class that begins first, because you might think that, well, the sooner I get started, the better it is for me. And that's one way to max out the number of classes that I can work with. So now we have not just one, but 3 proposed greedy algorithms. This would be a good time to pause the video and really think through these strategies. Think about which one of these would you be willing to place a bet on. Think about proofs, but also think about counterexamples. I would encourage you to not be easily convinced by these strategies, because some of them can actually be potentially non-optimal on some instances. So that's a fair heads up. Take your time trying to figure this out and come back when you're ready. All right, so I hope you've had a chance to think through that. At this point, let me reveal to you that actually none of these strategies are guaranteed to be correct all the time. And let's begin with the one that is perhaps, at least in my view, the easiest to refute. The greedy choice of choosing the class that begins the earliest could be a really terrible idea, because the class that begins first could also be the class that potentially envelopes all the other classes and blocks everything out, and it could be potentially the only choice that you're making. So think of an instance that looks like this. I'll grant you that this is probably unlikely to happen in practice, but it's still an issue in principle that prevents this greedy approach from being the right one. So if you pick the class that begins the earliest, it could potentially be one that starts at 8 a.m. and ends at 8 p.m. and therefore blocking out everything else. and you could certainly have a much better selection compared to this one. So this greedy algorithm finishes quickly after it starts on this example and is very evidently not optimal. What about the shortest class? Well, again, in general, it seems like a good idea, but you could have a really short class that has a lot of conflicts. In particular, you could have a class that looks like this. It's nice and short, but it conflicts with two non-overlapping classes. And at least in this example already, you would be better off picking the two longer classes as opposed to the one short class. And imagine just copy pasting this across the timeline, and you can see that greedy could be as bad as giving you only half of what the optimal choice could have been. It's a good exercise to think about whether you can push that factor to be even worse, enlarging the gap between the output of greedy and the output that you should expect from an optimal algorithm. Okay, so what about the greedy approach of picking the class with the fewest conflicts? This one is slightly trickier to come up with a counterexample for, but nevertheless, there is a counterexample showing that this strategy does not work either, and let me show you this on a separate slide. So here is an instance which consists of 11 classes laid out in this fashion. And to appreciate what greedy would do on this instance, let's actually write out how many classes each of these classes conflicts with. So for example, this class right here in the middle conflicts with two other classes, which are the ones right here. So let's put the number 2 next to this class to remember that. Now each of the classes on the top conflicts with 3 classes, the ones that you can see here at the bottom. They conflict with all 3 of them. So each of these classes are seen to conflict with 3 others. On the other hand, the classes that we just pointed to also have conflicts with 3 other classes. In fact, they have conflicts with 4 other classes. They have a conflict with both of these classes here, as well as the other 2 classes in their own column. So each of these would have a conflict number of 4 associated with them. So that's the situation that the greedy algorithm is looking at. And so the greedy algorithm will end up picking this class to begin with, which ends up consequently ruling out this class and this one. Now, once that happens, notice that you're left with 2 blocks of mutually conflicting classes, and you can only pick one from each of them. And in particular, greedy can only output a schedule with 3 classes. However, if you stare at this example, it should be clear that there is a choice of 4 mutually non-overlapping classes, and in fact that is optimal. So greedy falls short of optimal by just 1 here, but the point is that it does fall short, which means that it's not correct in general. Alright, so is there a greedy strategy that actually works, because we have ruled out quite a few natural ones? Well, it turns out that there is in fact a greedy strategy that works, and it involves picking classes that actually finish the earliest as opposed to the ones that begin the earliest. It feels like this was just a very minor change from a strategy that we had seen before that blatantly does not work. But it turns out that this minor change makes all the difference. It's going to be night and day, as we will see in the next video when we actually prove the correctness of this approach. With this discussion, I hope that I've convinced you about the importance of making sure that you really double down on formal proofs of greedy approaches that you come up with for problems that you are solving. So on that note, I'll see you next time.